Okay, let me explain it. Okay, so this is you can understand they can actually form an actual equation from a lot of things. Now, what I would say is this equation is probably from some type of subway station, or like in New York, maybe like there was escalator when you're trying to get off the station. When the train arrived, when the subway arrived, and those people get on the escalator, and maybe 5 minutes later, there's no more people on the escalator because the train already left. For 5 minutes, all the people already left. So this is probably some situation. And let's see if that situation kind of makes sense. Well, 300, this 300 second. 300 seconds is about 5 minutes. So kind of like if you read this, you say, oh, okay, well, this is 0 to 300 and this 0 to 300, 0 to 300, but anything past 300 is going to be 0. So that means train already left for 5 minutes. There's nobody get on the escalator. And there was people on the escalator just slowly getting off. Kind of like same situation. Except this situation is a little bit different. That between 0 to 33 seconds, train actually arrived at 33 seconds. You can see that very, very clearly later. So we're gonna see that situation evolve. So I hear the problem is 0 to 300. When you graphing, please don't graph from -10 to 10. You have to graph from 0 to 300. I do it more. I do it a little bit on the left side, so be let's say -10 to 320. And that's how I see my graph more clearly. So when I graph those, I will pay attention on those. Domain is something you have to pay attention to. Otherwise, your graph sometimes doesn't come out. It's not because your calculator doesn't like you. It's not because your calculator is sexist or racist in either way. It's just the calculator think you're dumb. So what you need to do is read your question and understand, okay, it's on 0 to 300. So that's my x min, x max will be. Okay, so if you get to this part, you say, okay, well, how many people enter the line? The A was easy because that's purely just integration. And this is the rate in, there's rate out, there's initial condition, this is all the information. They say how many people enter in the line. That's the keyword. No initial conditions needed. So it'll be A, integration between 0 to 300. You have to write down this. For people like Ethan, people don't write stuff down. Okay, 0 to 300 R of t dt, please write down like this. As minimum you have to write down, you just have to write down integration of that function. You don't even have to write down the whole function. But you do have to write down this. You cannot just say it's 270. Okay? But people write really small and just like really just answers, like Ferris just write down answers all the time. That they're not gonna cut it. You have to write at least that. So Ferris, make sure you write down this part in the front. I think you will do that. Just do that for the test. I mean, then if you're taking a test on FRQ, I'm gonna grade the same aspect, same way. So now B is gonna be between 0 to 300. There are always people in the line, but the problem is the people get in and there's people get off. When the train arrive, those people gonna get an escalator, but there's also people get off an escalator. So those are the things you're including. How many people is in an escalator? Well, there are 20 to start with. And there are people that is coming in. So be 0 to 300 of R of t. Now, those are people getting out. So that's minus 0.7 dt. Now, some people do it differently. Some people do it after the integral and just 0.7 times 300. Now, that's the same thing because 0.7 integrate 0.7 is going to be 0.7t. It's going to 0.7t times 300 anyway. So this one will end up to be 80 people. Any questions so far, Daniela?
Why do you subtract 0.7?
Because there are people come in, is R of t, and there are people getting off at the same time between 0 to 300. There's always people getting off on that escalator, which is 0.7 people per second. Joanne, does that make sense?
Yeah, I get it.
You get it? Okay, good. So this, always understand net equal to in minus out. Anytime you have net rate, it's in minus out. You had to minus out. Not 0.7 t though, it's 0.7. But if you integrate, it's going to be 0.7 t. Now net is also look like a velocity or rate of change, right? Rate of change. So this pretty much is the same thing. Net rate, velocity is the same way. Rate of change is the same way. Now you understand that? Now C is only part has nothing to do with calculus at all. So you start with 300 because they say is t is greater than 300. Because it has to be 300. After 300, there's no more people getting on. All the train people already get on escalator. And the train already left. There's no more people coming out of the train. So after the 5 minutes, there's no more people getting on escalator. But there are still people getting off. Does that make sense? So it's gonna be 300 plus. Well, there are 80 people left. And all you gotta do is divide it by the rate, which is 0.7 people per second. This is second. You can actually add up. People and people cancel out. Second move to the on the top. So it'll be 414.268 seconds. So that's C. Because there are 80 people left, and every second there's only 0.7 getting off. So you divide it by 0.7. It's like if you have 80 miles and you drive 10 miles per hour, right? So you're gonna have to drive 8 hours. 80 divided by 10. Does that make sense? Okay. Now for part D, you say, okay, what number of people in line is minimum to the nearest whole number? So this one's kind of hard to think about. But first of all, look at me. Think about it this way. If I throw a marker upwards, right? Eventually, if I throw it up, it's gonna come down. So I can catch. But if I throw it up, what happened? There's a positive velocity as I'm going up. But the gravity is pulling the marker down. Eventually, at highest point, what's my velocity? 0. Remember, velocity is like the rate, net rate. So you want the net rate equal to 0. If net rate equal to 0, it's going to give you a maximum or minimum. In this case, they are looking at a minimum. So you still have the net rate equal to 0. Their reason, certain situation reason is this. If you think about water bottle, okay? And I'm going to use a scale so that way you can see. So let's say water bottle is like right here. Now at first, if I have 4 units comes in, so I use like 1, 2, sorry, there's a 4 units, so it's 4 spaces. And those 2 units goes out. The water bottle is gonna start fill, right? It'll start going up. Does that make sense? But what's the only time they're gonna stop? The water bottle is gonna stop going up. Is when this slowly increasing to this point where the in equal to out. That's when you're gonna stop, because you keep on increasing, but this out is start leaking more. Then if you start leaking more in same rate as going in, you're gonna hit your maximum. The same rate going down as well. The same way it's going down as well. So if it's going down, which is this situation is more like going down rather than going up. So there are 2 units comes in, and there are 4 units goes out. The water is gonna start going down lower and lower and lower because there is less coming in, there's more going out. But if I somehow that this is it start decreasing, but if somehow this is equal, then that's gonna be where to stop, and that's where the minimum happens. Does that make sense? Zach, does that make sense?
Yeah.
Are you sure?
I mean, the water bottle makes sense. I don't know how it applies to the question.
Okay, so we're gonna look at the question. So remember, velocity is like a rate, right? So we can set the net equal to 0. Why is net? In equal to out. That's the same situation. So in minus out is equal to 0. So that means R of t minus 0.7 is equal to 0. So guess what? This is the part when they reach minimum or maximum. This has to be true. The rate has to equal to 0. Now, how do I do that in terms of graphing? So what I'm going to do is I'm going to go to menu. I'm going to go to doc. I'm going to tab this part. I can go to graph. I don't know how to graph. Anyway, I'm going to just restart a new thing. So I'm going to do new graph. And I'm going to say, do you want to save? No. Okay, so I'm going to say add a calculator. And I'm going to add a graph. Okay, I don't know why it's still there. Huh?
Go to graph, press tab.
Go to graph, press tab. Okay.
Trying to find the equation.
Tab.
Yeah.
Okay, so
No,
okay, so this is the graph. I'm going to graph. But the problem is, you see that straight line? Why do you see a straight line? Whoa.
because it's equal or because the second one is equal to 0.
No.
Well, the bounds go from. I don't think the bounds are. 0
The
to
bound's
1.
not right, right? So on your graphing calculator, you need to change the bound from window zoom to window setting. And you want to change it from maybe -10 here to maybe 310, I would say. 310. And now I click the graph. It will come out a very nice graph here. Do you see that nice graph here?
Yeah.
Now this is the in rate. I'm going to go into tab again. I'm going to graph. Wait, how do I do tab? Tab. Okay, I'm going to go to the second graph. I'm going to graph the y1 minus 0.7. Why do I need to graph that? That's the net. I'm going to graph the net. I'm set the net equal to 0. So then you're going to get this 0 right here. And I'm going to go back up. I'm going to ungraph this. I'm just going to focus on the red line now. This is the net out, net in minus out. Does that make sense? I can find the 0. So second graph. No, second analyze the graph 0. I'm going to click this one and this one, which is roughly equal to 33. And I'm going to do that same thing. I'm going to get 167. And that's the coordinate I see. I don't know what the heck is this. Something else. Oh, this is something else. Don't worry about that. So 33. This is what I'm paying attention to. Now, you see this one is the net. This, how many people is getting off the escalator? This small area below x-axis. You know, at 33 seconds, your train arrived. Ethan, wake up. Your train arrived exactly at 33 seconds, and here is going to be people getting off the train. And that's why it creates this. And that's how you get this. Now, how are you going to get credit? Why I wake up Ethan? Because you had to do a table here. And you had to do it at 33 because this is a net graph of net velocity graph, net rate graph. This graph at 33. So then you say, okay, well, what I'm going to do is I'm going to go back to calculate screen. And I'm going to go to here. I'm going to do this one. I'm going to do this one. Why I do this one? Because I have 20 between 0 to 33 of the net rate. Does that make sense? And I press enter. And this will give you 3.8, which is round out to be 4 people. At 33 seconds, the train just arrived. There's a minimum amount of people because the train just arrived. The door haven't opened yet. Soon as after 33 seconds, the door opened, people start rushing out. Does that make sense? So therefore, they are 3.83. So how do you get a credit? For Ethan or all those people, you want a justification. You want a 0, 300. And you want a 33, and you want a 167. This one's going to be 80 people. This is going to be 20 people. That's the end point. Always evaluate endpoint because endpoint might be the minimum or maximum. 33 is going to replicate 3.8, which is roughly to be 4. 167, I think is going to get 158. If you do integral between 0 to 167, so you can say at 33 seconds, you have 4 people in the line. 4 people, 4 FOUR at the escalator, which is the minimum. Okay, so that's how you get all the marbles here. You can get all 9 points here. Very difficult question, especially the last part. That's the first time you encounter a net rate situation. You have to set the net equal to 0. Then you can find minimum or maximum, depending how they cross x-axis. Remember, net is equal to velocity. If they cross the x-axis, more likely provide a relative minimum or relative maximum. Good? Do you understand how to use calculator? Do you understand change in domain? Don't ever graph the integral on your graph. You will get an infinite spinning wheel, and that's where it's bad. Like I said, your calculator is not sexist or racist. You are just not smart. Because I already told you. Okay, so this is a second style question, which is velocity. We've done this before. I also including extension parts. More likely you're gonna get those 8 choices. You're more likely gonna get 4 choices on the velocity question. Now, this question is a little bit different. This question has 2 particles instead of 1 particle. All the question we deal with on the test before is only has 1 particle. This one has 2 particles. You should be able to do A, B, C, D, E, F, G, H all the way through. I'm gonna guide you all the way through, but you can get a head start. You got a 5-minute head start, and then at 2:05, I'm gonna start going over. It's keep on going if you got it right. Just check your answer. If you got it wrong, then that's where you stop. Ethan, get a calculator. I have one here. If you don't have one. First 3 parts should be a very easy. Part D is a little bit different. What? What'd you say? That's what I thought. If I were you, I'll be able to do this all 8 parts in 15 minutes instead of 4 parts. Because the first 4 parts, it should be done within like 3 or 4 minutes.
You gotta do all the window settings.
Got 1 more minute before I start first part.
That was already 5 minutes.
You should already finished 3 parts already.
Not actually not a real word.
Okay, I'm gonna start typing the equation. So I'm gonna go to graph, and I'm gonna tap. Oh, I do have an equation already typed in, which is nice. But do you see this graph is right here? I'm gonna go back to tap all other graphs. So I'm gonna go to here. I'm gonna ungraph all other ones. So I ungraph this one. I ungraph this one. I want to keep this one. But the problem is, if you don't do window, you see this graph like this, because you got 0 to 300 now. And that's why your graph's not showing. But according to your domain is what? What's your domain on this question?
0 to 4.
0 to 4, good. So I will do 0 to 4. So I will do window setting between, I will do 0 to 4 according to Zach, and I'm good with that. I usually do -1, but that's fine. 0 to 4 is good. There's a very nice looking graph right here. Yep, very nice looking graph. Now, that doesn't really help me, so I'm gonna go outside screen. I'm gonna go calculate. There is a way to do this, which is this way. It's kind of interesting. You had to find the derivative because you got SVA. You want to take a derivative to get acceleration. So I'm going to go to calculus. And there is one here that usually you don't find things. It's derivative at a point. TI-84 has a derivative at a point, which is at a math 8 or math 7. They will give you x equal to, but for TI Inspire, there was a special place. So x equal to, I think they want to add 3, right? Yeah. And then plus OK. And d to the dx, we're going to set f3 because that's where I set my f3 is. And then x. And then I think close the parenthesis and then enter. It should be to get 2 point. So I will say d to the dt at v prime of t at t is equal to 3. This one is equal to negative 2.1182. Now I will write down the notation correctly if I take it to respect to time, and I plug in t equal to 3 when t equal to 3, and that's perfect. How do you get velocity? How do you get positions? Yeah, but there's something else too.
You have to use the initial condition.
And then you subtract 5.
Yeah. Initial condition, good. So between 0 to 3, v of t, right? Yeah. Which is, we can do that here. We can do menu calculus. Do they have integral? They do have integral. Between, I think it's between 0 to 3. And bar f3 x. I don't know why they want to type me an extra x. That's so bland. -5 plus. You can type in the front, and I'm gonna press enter here. I got -1.76. I don't know if that's right. What's the difference between integration v of t and integration absolute value of t? What is what though?
Absolute value is total distance.
There we go. And what's v of t? So total displacement. You have to write it down. And this one is total distance. And I'm just gonna do all once. So I'm gonna do another way is shift plus. Oh no, I have to do shift plus. Between 0 to 3.5. Most of you guys use TI and 84. You should know how to do this. Absolute value. Do you know what the absolute value button is in your calculator?
Go to yeah, go there.
Yeah, but for TI 84, the people knows where it's at.
It's gotta be in how do you do the thing?
Catalog, second 0.
Second 0.
The first thing, ABS.
No, but he has. I'm still on the for negative thing
What?
the thing so like automatically.
Okay, do I calculate? Menu.
So I will get total distance equal to 3.737. What do you guys think? Displacement's gonna be greater or lesser than this total distance?
Think.
Probably,
It can't be more. It has to be less, right? Because total distance is probably the greatest. So that'll be actually good. Multiple choice question? I don't know.
Gotcha.
So I have this, and I can do. I can go up here and just retype this, which is. I'm just gonna get rid of the negative sign. Get rid of absolute value sign. I don't know if I can do that. No, I cannot do that. That's dumb. And I'm gonna press enter. So it'd be 2.84, which is less, which is kind of interesting. We predicted that. 2.843. So we figure out total displacement, total distance. Do I need an initial condition when I find out total displacement distance? No, because it's not needed. Because we only ask total between 2 times. I don't care about where you start. You can start at the moon. I only care about first 3 seconds. I see how fast you run at the moon, which is at the moon probably gonna be slower. Yes.
it should be in radians.
Yes. That will help. Yes. Rule number 1, your calculation should be in radian. Rule number 2, never graph the integrals. Ever. And if
Rule number 3, no decimals and fractions.
no decimal infraction. And if you want to sacrifice your own grade, just yell out before we start calculus section. Just say, change your calculator to radian, and you get disqualified, but you get everybody pass.
I would even take one for the.
Take one for the team.
You know, I don't think I wanted to torture myself this year just to. Yeah, you know the sophomore slot. After this, it's sophomore slot.
Exactly.
I remember one year, my other friend teaching calculus went to the room and told everybody to change your calculator. The test coordinator was so mad at her. She's like, you can get every student disqualified right here before you even started.
By like helping them.
That's what's up.
Because you helped the student, you told him to change your radians. So part D, do you know how to do it?
Set the derivative equal to the original, like that one, and then the derivative.
X.
Oh, okay. Let's just graph the interval. Then we find the intersection.
Not funny, not funny.
Come on, that was good. That was a good one.
So I have to do.
I said just graph the integral of that and then find the intersection.
You know what? You're right. Let me do it right now.
I'm not wrong, Mr. Yet.
Sure.
Oh.
You can be the one to take it for the team.
Oh, why don't we have a sophomore do it? They have 2 years left after this.
Daniela? Nothing. What?
Daniel, you take calc 3.
They say at t equal to 2 is particle A is the first one. Speeding up or slowing down.
I mean,
Huh?
not that I decide.
For F,
That's
also
right
particle
now,
A.
so-
Everything's particle A except D.
Like, what did you do in 8th grade?
Algebra 1
And she take it to online class.
during COVID.
Because she's so bored at home, just take extra math class.
I was joking when I said take the integral.
Okay, so I just want to take a derivative of this. And it's equal to 2t minus 1. And I want to set it equal to 2t minus 1 is equal to v of t. So best way is to graph this. 0 equal to v of t minus 2t plus 1. So you just graph this. So, and then looking for 0 between that. So what I'm gonna do is I'm gonna go graph this. So tap and tap, and I'm gonna graph variable.
Oh, comment.
Wait, what happened? What did I just did? Variable
You don't need that new.
F3. Why do I have an equal sign?
Can you please exit? Like press back. Space.
What
Escape.
the
At the top left, escape.
escape?
No. That's not what I meant.
Tab. There we go. Graph var F3 of x, and I want to do minus 2x plus 1, right? So minus 2x
Explain yourself.
plus 1. Why is that? I want to set the graph equal to 0.
Wait,
If I graph the 0,
You have to get Jacob.
Is that a parentheses?
yeah, F3 of x minus 2x plus 1, yeah. So I'm going to graph this, and I press enter, sorry. Oh, this is the point here. So I'm going to look for the zeros, trace, analyze in zeros. This graph from here to here. 0 is 1.57, I think.
Yeah. That's kind of whack. You know, there's another way to do that. Yeah.
I like my way.
Okay.
Okay, so that is part D. Now part F. Part F is I want to graph the derivative of F3, so I'm gonna do tap. I'm gonna do d to the dx, so I'm gonna do control minus or shift minus, sorry, shift minus of x of F3. So F3, so I'm gonna do F3 here. F3 is my function of this. So x, and then I'm gonna graph this, enter. And obviously I'm gonna see, can I do a table? How do I do table here?
Go to menu.
So I'm gonna tap, I'm gonna uncheck all of them so that way I don't get confused.
Menu.
You don't have to uncheck them.
I don't have to uncheck them, but I'll uncheck just in case. Menu,
Menu. And then go to
table, right?
split screen table.
Split screen. You want it at 2.
You can go right.
Go right.
Your equations.
Move right.
Oh, I can because I just unchecked that one. Oh no, I do. F3, sorry. F3 at 2. Oh, at 2, right? At 2 is 1.99 positive. And F5 is negative, so slowing down. Slow down, right? So V prime of 2 is equal to 1.29 negative. And V of 2 is equal to 2, 1.99, sorry, 1.99. So therefore, slowing down. How do you find average velocity?
Position B minus position A over B minus X.
Yeah, but you have to integration the velocity because you don't have position functions.
So it's integration.
So you integrate V of t between 0 to 3 and do that. So I'm gonna go ahead and do that. I'm gonna do control plus between 0 to 3. And I know it's a var F3 x dx. Now, please don't get confused. It's derivative of that. It's not derivative of that. So it's x here. And I press enter. I divide it by 3. So that should give me 1.079. So it's equal to 1. Did I get it right? I take an integral of f3, which is the velocity function divided by 3. How do I find the furthest left and furthest right? I need to do a table, right? So let's say 0 to 4. And the function I want interesting to graph is the menu, the tab. Is which function I'm interested? How do I get rid of split screen?
Plus menu.
Plus menu,
Okay, go to table.
table,
Remove table.
remove table. There you go. So this one, I forgot this one is which graph. I'm gonna go into graph. Not this one. I'm gonna go graph this one. And between 0 to 4, I'm gonna go with 0 here. Guys, I'm recording, so just be quiet and leave. 2.8 and 2.8 and 4. So I will have a 2.8 and I will have 4 here. So at 0, what's my particle at -5, right? And at 4 is the integrate between that. So I'm going to do integrate of 2 things. So I'm going to do menu. I'm going to do untap. I'm going to do menu. I'm going to do integral is shift plus. And I know it's going to be -5 in the front. Plus between 0 to 2.8. Between 0 to 2.8. And I will have var 3 because that's my graph of x. That's my sign of things. That's what the one in the questions. X here and press enter is going to be -1.709. And I'm going to do the same thing again, but I'm going to do it to 4. So I'm going to do it to 4. So I'm going to delete this to 4. And press enter is going to be 2.372. Now, what's the furthest left? Furthest left is going to be
0.
left. And this furthest right is going to be here. So that's going to be furthest left and right at 7. We do the endpoint and the critical point, and I did the critical points. An average acceleration, just do f of 4, just do v of 4. So that's going to be v of 4 minus v of 0 over 4 minus 0. So v is the f3 functions. So I'm going to do f3 functions. So var f3 of 4. Wait, 4, right? Minus var f3 of 0. And I can press enter and then divide it by 4 and I'm done. Is 0.019 equal to 0.019425. And I just finished all the velocity question and all the net rate question. Got it?
Yeah. Do we have homework?
Yes, you do. You don't have prom today.
Oh.
Darn.
What is that? I was reading.
Bye. Do your homework, Zach. Don't be staring at the screen. Bye.